Okay, so we've calculated some statistics in Excel using their functions. However, there are easier ways to do this, and we have professional packages, including Jamovi, which is a statistical package that sits on top of the R language and is therefore very useful to researchers. So I'm going to copy and paste these data. So here's the data from Suffolk and Norfolk. I'm going to copy that, so I can right-click copy, or I can Control-C, Control-V it, and I'm going to take that to Jamovi. And here's Jamovi. So it looks like a spreadsheet, but it works much more like a statistical package like GenStat or SPSS or SAS or something like that. And we're just going to put the data in first. So let me show you how that happens. I've copied everything, including the column name. So if I right-click and paste it there, you can see I've got the data. But I don't want the column names here. I need them at the top there. And this is where we have to do a little bit of organization. So here, the first column, I've copied the column names in there because I need to copy them up here. So I double click the column title, and A, I'm going to replace with Norfolk, which is why I copied the titles over, so I can remember what they are. And these data are decimal continuous data. So if I go to here, it's not nominal, which would be text or categories, automatically detected because it says Norfolk at the top. But if I change this to decimal, boom, it changes that to continuous, and it actually deletes Norfolk from my title. If I move across to Suffolk, I'm going to write Suffolk here. And again, I'm going to change this data type from text to decimal, and nominal will change to continuous automatically. See, continuous. And we're ready to go, except I need to delete that missing row now. So right click, delete the row. Yes, please. Okay, so I can get rid of that with this upward arrow. That hides everything there. And we're going to do some exploration, some data analysis, just descriptives. So hit exploration, descriptives. And here we can already see a blank table set up with a few descriptive statistics already there. So I'm going to add Norfolk. I click Norfolk, move it across with the arrow. I'm going to move Suffolk across with the arrow as well. And then already I've got a table descriptives with my N values. There's 15 in Norfolk and 13 in Suffolk. I've got missing values. There aren't any actual missing values in Suffolk, but that's quite useful if you have a complete data set. I've got my mean and median, standard deviation, minimum, maximum. That's all very well. Sometimes I might want a table in a sort of wide format here, so I can change it to variables across rows, and therefore Norfolk and Suffolk is here and my descriptors are across the top. It looks neat and it can fit a particular thesis, but actually it's generally better to have the data in columns with your two comparisons side by side. So we're going to stick with variables across columns. I want to add a few more descriptive statistics to that. So here I'm going to go to statistics, and here you can see what I can actually add to the pile. Standard error of the mean is always a useful one, particularly when we've got an inferential test like a t-test involved. So I'm going to click that one there, and it automatically puts it in the table there. Also useful is the normality test. So I'm going to do Shapiro-Wilk. Strictly speaking, we should look at the residuals, but it's going to be indicative here. Here's the Shapiro-Wilk test statistic, the W, but the p-value is the one that we're interested in. Remember, this goes from 0 to 1, and if it's significant, it's a significant difference from normality. So here, this is very far from significance. This is near the maximum of 1. Suffolk is getting closer to our 0.05 threshold, but is still could be considered a normally distributed sample. If we wanted to look at that in further, there's also a very useful plots function here with a few options here, but histogram is really nice. So if we go to the histogram, there's our histogram for Norfolk, and you can see a vague normal distribution, but with the few data, the 15 points, we're never going to get a very compelling argument for normality or otherwise. And with the 30 points of Suffolk, again, it's very flat, apart from this very steep one in the middle there, which means, you know, it's more of a departure from normality reflected in that lower p-value. So if we go back from the descriptors, we can go back to our table here. If I want to take that back into Excel, I can just right click and I can copy the table, and I can go back to Excel. I can just copy in the table up here. and there's the descriptives, and you can see that that's a very powerful tool in our data analysis. Thank you for watching.